3.4. Another point T with coordinates PP, where P is greater than 0, is plotted such that ET is equals to BE, which is equals to 4 root 17 units. Calculate the coordinates of T. Now on here, I just randomly chose a point in the first quadrant and made that T. And this will just help us to visualize things as we work through the problem. Now B to E is given as 4 root 17. This is also 4 root 17. So using the information given, our task 3.4.1 is to calculate the coordinates of T. So how do we calculate the coordinates of T? Luckily for us, both of these coordinates are or have the same value, which means find the coordinates of one, find the coordinates of the other. But how do we do this? So we've been given distance as a clue. That means we have to use the distance formula. So writing down the information we've been given, ET is equal to BE, which is equal to 4 root 17. Then I'll keep ET, but I'll make the substitution for BE with 4 root 17. Then what I'm saying now is the distance for ET is 4 root 17, which is true because that's what has been given. And with that, I'm gonna formulate or use the distance formula, of which that would look like this. You have your square root, then you have the difference between your two coordinates. So here, since it's between T and E, I'm gonna have 12 minus P for the X part plus 0 minus P for the Y part. And then this is equal to 4 root 17. Then immediately what I'm going to do is I'm going to square both sides so that I can get rid of the square root. By doing that, on this side I'll be left with 12 minus P. We can factor that out, or we can simplify it out, and that would be 144 minus 24P plus P squared plus 0 minus P is just minus P squared, that's just P squared. And then on this side we have 4 root 17. If you put this on your calculator, it returns 272. Now you have this problem. And then what you're going to do is you're going to collect the like terms. So here I have P squared plus P squared is going to be 2P squared minus 24P, and then plus 144 minus 272. And if you put that on your calculator, you get minus 64. So this returns minus 64 is equals to 0. Or it actually returns 124. Minus 124. Then we can divide through by 2, since all of them are multiples of 2, and working with the coefficient on 1 on the variable that has a degree of 2 is usually better, because you might make less mistakes. Or from this point you could use the quadratic formula. That is still an option as well. It will return to you two values of P, of which you choose the correct one. But if you decide to go the route of dividing through by 2, you have P squared minus 12P minus 64. And this is supposed to be actually 128, not 124. So you can use that with the quadratic. And then P squared minus 12P minus 64 is equals to 0. You find the factors of 64 that when you add give you minus 12, and multiply they give you minus 64. So if you look through, you'll find that 16 and minus 4 will be those values. So minus 16 over here and plus 4. Minus 16 plus 4 is minus 12. Minus 16 times 4 is minus 64. Then we can write down our answers. P will either be 16 or P will be equal to 4. And this is negative 4. But from the information given, we know P has to be greater than 0, so this answer is non-applicable. And our answer is P is equals to 16. Therefore, the coordinates of T are 16 plus 2, 16.